Yeah, you could probably have a scenario where, let's say, if the buildings used half as much cement and the cement contained half as much limestone, then we would be down to 25%, and that could, I mean,
go far. Yeah.
I think the CO2 emission is clearly the big one. So I think if they can solve that, crack that nut, it will be a huge step forward. And the technologies to, let's say, crack half the nut is available.
Hello, Joachim from Green Innovation Group here, still working on making the healthcare sector sustainable. We're doing a lot of interesting projects at the moment, working with pharmaceutical factories all around the globe on how to make them circular and how to take the general sustainability strategies and actually implement them so that they become executable in an everyday life and create value at the specific factory. And we are also working with public-private partnerships on the commercial side of things, bridging between healthcare systems and medtech and pharma companies. That's super exciting. And also working on some cool stuff around value-based healthcare. So if anything of that sounds interesting, feel free to reach out. But today we are talking about cement. And why are we talking about cement on a healthcare podcast? Well, because most healthcare happens in buildings, and most buildings are built with cement. And cement is a huge CO2 emitter. It's one of the largest CO2 emitters globally. So I invited Skage into the podcast. Skage has a PhD in geology and is the former head of R&D from FLSmidth, a company that produces cement equipment. And we take a deep dive into how cement is made, why it's so CO2 emitting, and what can be done to change it. Hope you'll enjoy the episode. Take care. All right. Skage, welcome to the Sustainable Healthcare Podcast.
Thank you, Joachim. Pleasure to be here.
I really look forward to having you. You are not from the healthcare industry, but you are very knowledgeable about a lot of the components that goes into making a modern healthcare system. And today we're going to talk about cement. And you have a PhD in geology, and you worked as was a senior vice president, you're head of R&D for FLSmidth, a large cement manufacturing company that produces equipment for cement manufacturing. So, what was your story into working with cement, and what made you curious about that?
Well, cement, this little bit dull gray material, is immensely complex. It has maybe 25 different components, at least, that influence how it crystallizes, how it hardens, how you have to produce it, and then you have to make this material in very large amounts very cheaply. So for a scientist, that was a fantastic challenge in the beginning. So it was important that you take these raw materials that comes from nature that are heterogeneous and complex, and you have to produce a simple, homogeneous product that has very uniform properties.
So then when you build buildings out of it, you sort of know what you get.
Completely controlled everything. There's a large... You don't know it when you are on the outside of this industry, but everything is very regulated. There's both standards and legislation and everything, so that the products have to be of a very specific quality. And if the quality fails, it can have disastrous effects. So,
well, sense. In the healthcare industry, we have something very similar around safety and efficiency. So that should be well known to our listeners. And of course, why we're talking about cement in a sustainable healthcare podcast? Well, first of all, there's a huge amount of building mass involved in the healthcare industry. most of healthcare is done inside, whether that is the small office of a general practitioner or a large super hospital or the factories of pharmaceutical companies. And most of these buildings, I would guess, from what I've seen at least, are built in cement. Of course, some might be with smaller bricks. So there's a lot of cement in the healthcare industry because there's a lot of cement everywhere. And the other thing is that CO2-wise, it's quite costly to produce cement. And some of our listeners have asked, so could we do something about this? Because they just see it in the Scope 3 that this was something that the emissions are coming way before it reaches the pharmaceutical company or the hospital. So maybe let's talk a little bit about first. So rough terms, or how widely used is cement for building, and why are we using it? Yeah.
Cement, I mean, it's like a 2,000-year-old material.
Yeah.
Has very, very attractive properties. It's simple to make. I mean, you can make it in your garden if you had if you can make a fire that can light up to 1,000 degrees. You can make cement at home.
Oh. And the Romans did that.
The Romans did that,
yeah.
And many people did that, and they made cement that lasted for thousands of years.
Wow.
Very high quality stuff. Some of them, they knew what they were doing.
So is there still like alive, still standing cement that were produced from?
Yes. It's not that common, but yes, there is here and there. And you can find cement mills actually that or grinding mills that had the same principles as they have today. Some of the principles. Cement, when you make it, the challenge is that the primary component, the strength-giving component, is a calcium silicate. And it made from lime, chalk, which you burn at high degree. The lime consists of calcium and CO3.
And we're not talking about the lime, the citrus fruits, but the sort of
the rock,
from limestone.
Limestone. Yes, and limestone would be the correct term. Yes, and when you heat it up, it turns into calcium oxide and CO2, and that CO2 then has to go somewhere. And traditionally it was just let into the atmosphere, and for every ton of cement you made, you emitted roughly 1 ton of CO2, plus the energy cost.
So it's not only that you need a lot of heat to make it, it's also that you are releasing CO2 from the limestone.
It's exactly the same thing as with fossil fuels. You have geologically tied up carbon dioxide that is emitted when it's burned. Of course, it's a different process, but and because the calcium silicate that is formed when this reacts, when this calcium oxide reacts with the sand afterwards, or silica, it creates it's an inherent challenge. You can't get away from it in part today, but it is really you can't save energy and avoid it. For instance, you need to change the chemical composition of your cement somehow, and the principles of how that cement is made. And many attempts are made at this.
And you said we're using cement because it's has some very attractive properties. What are these properties?
It hardens fast. So it's very flexible. You can manipulate it so that it can harden in different environments. So it's you can store it easily, and I think there's no material that competes with it that is available in large. I mean, because it hardens in atmospheric conditions. So just mixing this up, waiting for an hour, you have a hard surface. So when you put the tiles on your bathroom floor, what you use there is actually a very specialized cement, which is very effective, and these kind of things would be far more complicated. You would have to use something like a glue or something like that that would have similar properties. So the properties is it can be stored easily. It is easy to mix on site and prepare, and it hardens with very high strength and very predictable properties. And this means that it has been a very successful material. Most buildings are built of it. And that of course, and then there's all the standards and references and culture and competences around an entire value chain.
So everybody is trained to use cement as well, and when you're doing tenders or whatever, it's a natural part of.
It's a huge value chain that is tied up in this, and everybody knows that it wants to reduce the CO2 emissions, but it's not easy for any one player to do so.
And roughly, what amount of the global CO2 emissions are coming from cement?
Depends on how you depends on how you calculate it, but I'd say at least 4% and maybe as high as 10%, depending on how you calculate. I think maybe 6-7%, something like that. But
so there we are actually more than the whole healthcare industry, which is 4-5%. And enough that it would be one of the largest countries in the world. If you just took the cement industry and made it into a country, it would be one of the most CO2 emitting countries.
Definitely.
And you said that it's hard to change because it's cheap and it works wonderfully. Is there any hope for CO2 neutral cement, or do we need to find other materials or more of an avoidance strategy?
I think both. I think the substitution with other materials is clearly, like wood and things like that, is clearly one strategy that needs to be used. But there's also, if you just go from the technology, the chemical side, you can substitute up to 50% of the limestone.
Okay.
It requires changes in the industry. It requires investments, but you can. And of course, it's difficult if you don't have the necessary raw materials. You can use calcined clay to a large extent. There are Danish startups that have developed this, and Eversmith also offers this kind of solutions. So 50% of the emission of the cement can be taken out.
And if
not easily, that's the best case.
Why you would want to remove the limestone is because the limestone is kind of like a fossil fuel. So when you burn it, it emits CO2.
Yes.
In high amounts.
And that's the primary source of CO2. So 50% can be taken out. Of course, I don't know how much these technologies are adapted, but I know there is a demonstration facility being set up for this here in Denmark by a Danish startup that is doing that.
But we're not at scale, and it's nowhere near common to buy cement like that.
But companies like Aalborg Portland are interested in this, for instance. And I think it's important because if you instead of saying we need to do the perfect and everything needs to change, that will happen very slowly, if at all. Taking the first simple steps, reducing, I think is very valuable too.
Yeah, but it also comes back to as with a lot of these things that the most sustainable building is often the building that we don't need to build, or the bridge we don't need to build. So thinking a lot about avoidance and not using virgin materials in the first place should be a natural first step, even if there are less bad virgin materials that you can use. But of course, it's also very complicated because I don't know a lot about it, but I assume that a lot of the cement being used is also being used in countries that are still building up their infrastructure and their development, where it can be easy for us here in the West to say, well, stop building your highways and your bridges. And
that's a very interesting topic, because there's like a curve when you have BNP versus per capita versus cement and steel consumption. There's like a curve that goes steep incline and then it plateaus. And China and Africa, India, are on this steep incline. And they, of course, need to build their infrastructure. They need to do these things.
So the richer your population gets, the higher BNP, the more you consume of cement and steel, and then it stops. I don't know, plateau, not stops, but it evens out.
The consumption of cement and steel in a country like Denmark or in Europe is not that high, but in China and India and Africa, it's growing fast. I think China has maybe plateaued. I don't recall the exact numbers now, but it's an interesting effect that when living standards reach a certain level, the consumption it stops increasing. Yeah.
I assume that you only need so many bridges and highways, and when you are at first when you're building cement houses or just stone. For some, it's going to their first stone house one way or the other. Then you need new for everyone, and then they have, given the properties of cement, it lasts quite a long while. So I assume that's sort of the effect that once the buildings and the infrastructure is in place, the half time is. It's not so high. So,
then they stand there for a while.
Yeah, exactly. For our clients, usually where that would come into their world in the healthcare industry would be that the company has grown, so it needs a new factory or a new office space, or some healthcare system is building a new hospital or revamping. How to think about cement in that context? I mean, I know you are not an architect or construction engineer, but
I would try to choose solutions that use less cement, and I would also, I don't know how this would work, but I would try to create demand that the cement, for them to use cement types that emits less CO2. I don't know if they're even commercially available, but at least it would start creating a push, saying what is the entire CO2 carbon dioxide footprint of the project, and then break it down into bits and pieces, and maybe that could creating a competitive edge around so that around low emission cement, so that producers could the cement factories could actually see a market for it, because they would need to invest heavily. I guess that also taxes will drive this development.
And you talked a little bit about before that it's a large and complex supply chain to change. Could you, in a high level step, talk us through that supply chain, and then
I'll do my best. I know the one end of them better than the others, right? So if we start in one end, you have the cement factory. They have access to raw material. They probably own the rights to mine limestone and clay and sand, which are the principal components of cement.
So build the factory close to the stuff because it's heavy.
They always do that. Factories that has been around for a while sometimes need to get stuff from other places because they exhaust their resources. Then transport of that cement, that's usually trucks or ships, depending on how far it goes. And you'll see that cement plants, they're usually like with 200-300 kilometers apart or something like that, because the transport expense become too big a competitive.
The value to weight is very high. It's costly to move. So
so the next step then is you can have concrete producers where they mix small plants where they could buy clinker or cement and then mix it.
And for our listeners, what is the difference between cement and concrete?
Concrete is you take cement and you add sand and gravel and water, and then you have concrete. Cement is the white powder that gives strength to the material. But actually, I think 2/3 of the material is actually not cement, or maybe even less. So you have
that's where when we see the trucks with the spinning where the spinning mixers,
cement mixers. They drive around with concrete that is prepared, and these guys then sell it to the entrepreneurs, I would guess, and they build the buildings. So both the entrepreneurs, and they are, I know, working on it, and architects who designed these buildings, they all need to be part of it somehow.
So there's also, what I also hear you saying is that there are some very large capital investments, CapEx investments in these things, both of course in the plants, but also in the supply chain logistics.
Ships and trucks and whatever, roads and railways. So there's a lot of players involved, and I don't know on the entrepreneur side. I don't have much insight into that, but I know there are many activities, of course, to replace these materials, and they with wood, for instance, and they're on the technical side. There are projects where they want to have algae, for instance, precipitating lime and let's say lime and organic components in modules that can be reused, for instance, and there are many attempts at making materials that can compete, and I think, but probably not enough attempts relative to the size of the sector.
No. I mean that's whether it's 4% or it's 10% of global CO2 emissions coming from cement.
Yeah.
That's like a lot. It's many more times the flight industry or whatever else we're talking about. So I think it's fairly safe to say that we can't really do the green transition without fixing the cement industry, or whether through changes or avoidance or whatever it might be.
You could probably have a scenario where, let's say, if the buildings used half as much cement and the cement contained half as much limestone, then we would be down to 25%, and that could, I mean,
go far.
And you wouldn't have to break up the whole. I mean, you wouldn't have to use everything anew, because there's very large plants and infrastructures already built, and of course, changing that would also have impact.
How long does a cement building stand? Or concrete?
I think it can stand forever, essentially.
Okay.
There will be some a millimeter or the surface of the cement building. If there are no cracks, not much will happen. But if there are microfractures and cracks, CO2 from the air will start react with it. So you will have it will start tying up carbon dioxide again. It goes slowly, but I've seen rates of maybe 1 millimeter per 20 years, but it requires microfractures in the material, and that's kind of the positive story, that nature being what it is, the calcium oxide will reclaim its CO2 if given a chance.
Are there any, besides CO2 emissions, are there any other negative environmental aspects from cement production?
From the fuel, you have NOx. But I think that's fairly controlled with filters and ammonia systems and things like that.
I assume that you also have some ecosystems impact on when you're gathering the raw materials, whether that's the limestone or the stuff later for the concrete.
The footprint of a cement plant is, of course, let's say half a square kilometer or something like that. Maybe a square kilometer with depending on size and things like that.
Including the dig-ups from the raw materials.
And I don't think that is relative to other things. That's a very small impact relative to this CO2 emission, I think. You do have dust.
Yeah, so it will be bad in that area, but it's relatively confined.
Yes. I mean, in that area, it will be like there's nothing happening there from nature's side.
Just everything is demolished.
It's an industrial site.
Is there high water usage or
not much? There a little bit, but that's not a problem in cement, I'd say. Of course, I mean, it's something that is considered. There is some water is used, but not relative to other industrial processes. I think the CO2 emission is clearly the big one. There's a lot of emission control and systems that monitors this. So I think if they can solve that, crack that nut, it will be a huge step forward. And the technologies to, let's say, crack half the nut is available.
Yeah.
So that's the positive news. It just needs to be implemented.
Yeah, unfortunately, that is the story for most of the areas of the green transition.
Yeah.
Is that we have almost all the technology that we need.
Yeah.
It's an implementation issue, it's a financing issue, it's a system change, mindset change issue. Much more than we need some fancy technological breakthrough to come. We need to use the tools that we have, basically.
Yeah.
It's always nice with new technology and stuff, but it's in no way a barrier of fixing things.
No, one could just start tomorrow.
Yeah. Which is also quite frustrating.
Yeah.
Hey, come on, we have the toolbox.
Yeah.
What are we waiting for?
But these companies, I mean, they are in a competitive environment, and somehow the change has to start happening.
Yeah, so it's one of those places where we need to price those CO2 emissions so that they become a sound part of the economic formula.
Yeah. And you have this, if you just taxed it in Denmark alone, well, what would happen is that Aalborg Portland would close and we would buy our emissions from Germany, and it would do nothing for the global situation. So one needs global, let's say, consensus around these things.
Yeah, definitely at one point. I mean, that's a complicated topic, and in general, I'm not a fan of leaving anyone out of CO2 emissions.
No.
But it's a complicated discussion. But thank you so much, Skage, for coming in and making me and our listeners more knowledgeable about cement, which is, to sum it up, one of the absolute key emission factors on a global level. That we really have to fix, and that is also quite present in the healthcare industry, even though we won't think about it. But if you're in a building right now, there's a very high chance that it was built with cement.
It is almost certain. Yeah.
Thank you so much.
Thank you.
Hi, Joachim back here. Again, thank you so much for listening to the episode. I hope you enjoyed it. And if you did, please share it with a friend who would also like to learn more about cement and sustainability. Really appreciate all the support for the podcast out there, both just from listening on it, but also on LinkedIn. Feel free to ask questions on LinkedIn if you have any. Then we'll do our best to answer. Take care.